Hi class, in this lecture here we're going to continue talking about financial mathematics by moving in and talking about this financial instrument or financial concept called annuities. And so the only thing we're going to be doing in this lecture here is talking about how you understand annuities. And there's going to be two formulas that we're going to introduce in this lecture here, and I'm going to work three examples of each. And the formula is going to look pretty complicated, but I promise you, by the end of the lecture, if you watch it, hopefully it seems very, very manageable. We're also going to make heavy use of our graphing calculator today, so make sure you have that handy as we go through these lectures. All right, so first off, what is an annuity? So for most of us, we aren't able to put a large sum of money in the bank today. So instead what we do is we save for the future by depositing a small amount of money from each paycheck into the bank. Maybe it's $100 every 2 weeks or $10 every 2 weeks, whatever. This idea is called a savings annuity. So most retirement plans like a 401k or an IRA plan and independent retirement annuity plans are examples of savings annuities, or an individual retirement account, IRA. So what an annuity is, it's a sequence of equal payments. Okay, so it's always going to be equal payments at equal time periods. So for example, something like $100 every month. Okay, that would be an example. So every month you're depositing an equal $100. And so what turns out the value of an annuity, so the total value of the annuity, is the sum of all the deposits you make plus all the interest paid. So the first formula, what we want to do here, look at, is how you determine the overall value of an annuity. All right, so here's an annuity. This is interest compounded n times per year. And so most often we're going to be doing monthly. Almost all the examples here. So in that case, n is equal to 12 in that case. All right, so here's the problem, or the formula. If P is the deposit made at the end of each compounding period, so P is how much you put into the bank, all right? Your deposit every month. Okay. Is made at the end of each compounding period for an annuity that pays an annual interest rate R, so R is going to be the interest rate, compounded n times per year. Okay, the value A, so this is the total value of the annuity after T years. Okay, so you're going to need to know four things. You're going to need to know P, which is the deposit. R is going to be the interest rate. N is the compounding times per year. And then you're going to need to know the number of years. Okay, so T is the number of years. Okay. The value A of the annuity after T years is given by this formula. It looks complicated, but I promise you it's not that bad. A, the total amount, is equal to P times, and then in parentheses, 1 plus R divided by N raised to the N times T power, minus 1. So you have to subtract away 1 from this value. Then once you figure out what the numerator is, you divide that by R divided by N. All right, and so we're gonna work a number of examples today, okay, in this lecture here, using this formula, okay? And so don't worry, I don't expect you to memorize the formula, obviously, so it will always be given to you, all right? All right, so let's jump right into this. So at age 25, to save for retirement, you decide to deposit $200, all right, into an IRA at the end of each month at an interest rate of 7.5% per year, compounded monthly. Okay? How much will you, question A, part A, how much will you have from the IRA when you retire at age 65? And B, it says next find the interest. So we're going to do A first here. All right, so you're just going to use this formula here. All right, the total amount of the annuity is equal to P, okay, which is your deposit. So let's just write what we're given here, okay? You're doing $200 a month times the rate. You're getting 7.5%, so that's, as a decimal, is 0.075. All right, compounded monthly, so that's 12 times a year. And then you have to figure out the number of years you're going to do this for. Okay? Well, if you're going to start at 25 and go to 65, right? That's 40 years. You're doing this for 40 years. So what you're going to do is you're just going to plug in the values into your equation. All right? And then you're going to watch me on the calculator do this. So this is P, which is $200, times, and then in parentheses, 1 plus the rate, 0.075, divided by 12, raised to the n times t power. Okay, so that's going to be 12 times 40. All right, and then I'm going to subtract 1. So a lot going on here. Divided by r, which is 0.075, divided by n, which is 12. All right, let's watch how I do this, okay? It's going to be incredibly important to follow along very, very closely on your calculator, okay? All right, so the first thing I'm going to do is I got to figure out what's inside the parentheses here, okay? Watch how I do this. So I got to figure out first what 0.075 divided by 12 is. Okay, it's that. And then I'm going to add 1. So then I'm going to go plus 1. And now I have to raise this number to the 12 times 40th power. To get this number. Then I'm going to subtract 1. And now look. Now I'm going to multiply it by 200. And then, last step here, I need to divide by this. Okay, so then I'm going to divide by, and then you have to put this in parentheses. This is really important. You have to put this in parentheses. 0.075 divided by 12. You have to make sure to put this in parentheses, okay? And you're going to get, wow, not bad. Look at this. This is amazing. You're going to get, just by doing $200 a month, okay, over a 40-year period, you're going to have $604,764.43. Okay, that's a lot of money. $764 and 43 cents. Wow. You're going to be, and think about it, $200 a month, it might seem like a lot now, but like over time, this money is, this is called the time value of money. It's growing. All right, so let's figure out how much of that money there was just from interest. Okay? So let me go to part B here. So find how much came from interest. Well, the interest you make on this is equal to the total value of the annuity so the total value of this annuity here minus the total value of the payments. So how much, you have to back out how much you actually paid, okay? All right, so we'll look. We know the total value of the annuity. It was $604,764.43. All right, well, how much, you have to figure out the total value of your payments. Well, look, you made $200 payments 12 times a year, so that's where the 12 comes from, times 40 years, okay? Because you did that for 40 years. So look, 200 times 12 times 40. So you actually deposited $96,000 into this account. The rest of it is just interest. Wow, this hopefully this illustrates and shows you like the time value of money here, right? Like your $200 deposit monthly, it grew very, 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 very quickly. Or grew very, very large. 604, 764, and 43 cents minus 96,000. You made over $500,000 in interest. So it's 508,000. $764.43. So a ton of money. You made a ton of money in interest. So, hopefully you're watching this lecture, and the first thing that clicks in your mind here is, wow, I should really start putting money away. Maybe investing it in the stock market or any savings instrument you can think of. Over time, you're going to get a lot of money. All right, over a long period of time, like 40 years here is obviously a really long time. So start planning for your retirement now. All right, let's do another example. So at age 40, to save for retirement, you decide to deposit $500. Okay, so let's write what you're given again. Given. Your deposit is $500 into an IRA at the end of each month. So you're doing it 12 times per year at an interest rate of 9%. Okay, so your interest rate is 0.09. And it's compounded monthly, so that's where the end comes from. How much will you have in the IRA when you retire at age 70? Well, T here, if you're going to start at 40 and go to 70, it's going to be 30 years. So look, you can see you're just going to plug it right into the equation. Again, here it's P times 1 plus R divided by N raised to the N times T power, then subtract 1. Divide that by R divided by N. Watch what happens. So $500, because you're starting late. 1 plus 0.09 divided by 12. Raise to the 12 times 30 power. And then subtract 1. And then divide that all by R divided by N. So 0.09 divided by 12. All right, so again, I'm doing this all in my calculator, right? I'm going step by step in my calculator. As you do these problems, right? Or watching my lecture, you should be checking too to see if you get the same thing. Okay? All right, so start the inside of the parentheses, the innermost. You're going to go 0.09 divided by 12. And then you're going to have to add 1. And then you're going to raise that to the 12 times 30th power. Then you're going to subtract 1. Now I finished everything inside the parentheses. I'm going to multiply that by 500. And then divide, and then make sure you put in parentheses 0.09 divided by 12. And then close the parentheses. Whew, lot of money. Look at this, okay? You're going to have, okay, $915,371.74. So you made a lot of money. So you can see here, $500 over 30 years gets you quite a bit when you're getting this 9%. So 915, comma 371, and then 15 cents or 74 cents. Sorry. So this person, is well situated, well situated for retirement here. All right, so again, let's find out how much is interest. So B here. So that's equal to the total value of annuity minus the total value of all payments, of all deposits. So this was, going back, 915,371 and 74 cents. Okay, so now to figure out the total value of payments, you're making $500 payments 12 times a year for 30 years. So you're making $180,000 in payments. So you can see how much of this is just interest and growth. So you made a ton of money on interest here. Ton of money on interest here. And look, so much money in interest. $735,371.74. Okay, so start investing now. You know, the more money you can put away, look at how much this money is growing, right? It's absolutely incredible how quickly it grows. All right, let's do one last one. And so what I encourage you to do is, you know, just pause the video as I'm doing this, right? And you know, give it a try, you know, see if you can solve it. And then I'm going to be quiet for a couple seconds. Hopefully you give it a shot. And then, you know, I'll show you, you know, what I get when I solve it here. Okay. All right, so hopefully you gave it a shot and paused the video. And if not, and you just want to see another example, let's jump into it. So at age 21, to save for a big trip you want to take, maybe you want to go to Europe or something, all right? You decide to deposit $100, okay? So that's your deposit, into an annuity at the end of each month with an interest rate of 0.06, so 6% compounded monthly. Okay. And the question says, how much will you have from the annuity when you take your trip at age 30? So if you're going to start at 21 and you want to go on this trip when you're 30, that you're saving for 9 years. All right. So again, just follow the formula. It's your $100 deposit times 1 plus R, which is 0.06, divided by 12. Raised to the n, which is 12, times t, which is 9 power, and then you're going to subtract 1. And that's all divided by rate divided by n. So 0.06 divided by 12. So hopefully you can see, you know, how I'm doing this in calculator. I'm starting right in the middle and working out, following my order of operations here. So I'm going 0.06 divided by 12. Then I'm adding 1. And then I'm raising that to the 12 times 9 power. And then don't forget what you can do. You're going to subtract 1. Then you're going to times by how much you're depositing, so times by 100. And then divide, and then don't forget to put in parentheses 0.06 divided by 12. Oh, look at this. You'll be able to take a pretty nice trip, okay? You can see how quickly your $100, you know, each month blew up here. So you got $14,273.99. Okay. So again, let's, you know, the last part here, you can see the pattern here. Let's find out how much of this was just interest. So total value of annuity minus the total value of deposits. So again, by diligently saving, you had $14,273.99. And so your deposit, so how much were you depositing? You were doing $100, 12 times a year for 9 years. So look here. 100 times 12 times 9 was $10,800. So not as much for interest because it's a lower obviously deposit, but lower time frame. Like you can see here, when you're saving for like 40 years, the value can get really, really high. But when you're only saving for 9 years, it doesn't blow up as quickly. All right, so you made $3,473.99 in interest. So not bad, still, hopefully maybe that can upgrade your flight to first class. Okay. All right. So now what I want to do is switch this around a little bit and talk about how you solve for a deposit here. So maybe you have a goal in mind. Okay. So this is planning for the future with annuity. So you have a goal in mind, and what this formula here does is it helps you solve for how much you have to put away. All right, so the deposit P, so you're solving for the deposit that must be made at the end of each compounding period into annuity that pays an annual interest rate of R in decimal forms, compounded n times per year in order to achieve a value of $8. Okay, so what these problems are going to be is basically it's going to say, okay, if you want to have, $50,000 or something, how much you have to put away each month. Okay, so you're going to be given A and solve for P. So it's this. P is equal to A times R divided by N, and then divided by 1 plus R divided by N raised to the N times T power minus 1. Okay. So a little bit harder formula to do, but we'll be able to handle it. Okay, so here's the problem. Suppose the first example here, and we'll do 1, 2, we'll do 3 examples again, okay? Suppose that once you complete your college education and begin working, you want to save $50,000. Okay, so that's how much you want to have saved. You want to have saved $50,000. Okay, over 10 years. So over 10 years you're going to save. So you're given 10 years to use as a down payment for a home. You anticipate making regular end-of-month deposits into an annuity that pays 9% compounded monthly. So 12 times per year, and the rate is 0.09. So here's the question. How much should you deposit each month? And how much of that $50,000 down payment comes from deposits? And how much comes from interest? Okay. So again, you're just going to have to use the formula here. All right. So here would be part A, figuring out how much you have to put down. So you're going to put down, just follow the formula, plug it in. You want to have saved $50,000 times R divided by N, so it's 0.09 divided by 12. All divided by, and then here, okay, so this is 1 plus 0.09 divided by 12. And remember, you're doing this for 10 years. Okay, so it's n times t. So it's 12 times 10 minus 1. Okay, so this can be a little bit trickier. Okay, and so watch. You have to be very, very careful how you do this in your calculator. Okay, so watch me, and then what I encourage you to do is, like, make sure that, after you see me do it, follow along in your calculator on your own and verify that you can get the same answer. All right, so let's do the numerator first. So it's 50,000 times 0.09 divided by 12. Okay. And it's $375. That's just the numerator, okay? All right, so now let me figure out what the denominator is, okay? So you're going to go 0.09 divided by 12, and then you're going to add 1, okay? Then I'm going to raise that to the 12 times 10 power, and then subtract 1. All right, and you notice how you got this number that's like not nice and neat. And so if you're going to, you can go out 6, 7 decimal places here. That's totally fine to plug it in. But then there's also this button here, this X inverse button. Okay, but let me just write this down in here. It's 1.4513, and I'll go 57. $357. So you have to go out quite a number of decimal places here. So look, if you actually just hit this X inverse button, all right, and then go times 375, you'll get the right answer. So you're going to have to put away $258.38. Okay, $258.38. And if you don't do that, and you had just do this, the answer is just going to be slightly different, but not off all that much. So you can see you have to go out in a really far number of decimal places for it to matter. Okay, so if you need to, if you don't want it like doing this like, full step in your calculator here, go out 6 decimal places or so here for the denominator here. All right, so if you want to have $50,000 after 10 years, all right, and you're getting this 9%, you got to put away $258.38. All right, let's figure out the interest, okay? So the next said, how much of that $50,000 down payment comes from deposits and how much comes from interest? Okay. All right, so let's figure out the deposits. Well, look, deposits, you're going to be making $258.38, 12 times a year for 10 years. Okay, so your total amount of deposits so 258.38 times 12 times 10. Look at this. Your total deposits were $31,005.60. So then to figure out the interest, how much you made in interest, well, take the $50,000 total you had and subtract away your deposits. So it's down payment minus deposits. So 50,000 minus 31,000, $5.60. So you did pretty good. You made $18,900 $194.40 in interest. Okay, so start saving now. Start saving now for that down payment, okay? All right, let's do another one, all right? So suppose you want to save $250,000 for a retirement fund in 30 years. So you're given A, all right, and you want to save for 30 years. So you're given your time horizon here, it's 30. You anticipate making regular end-of-month deposit into annuity that pays 4% compounded monthly. So you got your rate, and then it's compounded 12 times per year. Okay, so again, it's the same question. How much should you deposit each month? Okay, so I want to figure out how much I have to put away, so I have $250,000 saved up. Okay, and then I want to figure out how much of that $250,000 fund comes from deposits and how much comes from interest. Okay, all right, so deposits. Let's figure it out. Part A, how much am I going to have to deposit? So I want $250,000. I'm getting 0.04, that's my interest rate, and divided by 12. Divided by 1 plus the rate divided by 12 raised to the, well, how many years? I'm saving for 30 years, so it's 12 times 30, so raised to the 12 times 30 power minus 1. All right, let's do this. Numerator, 250,000 times 0.04 divided by 12. And so here, okay, you get $833. And remember, if you're gonna do this, go out 6 decimal points here, so because we want to get this as accurate as we can. So 833.33333. Excuse me. Sorry about that. Divided by, now remember, this one we're going to go out a significant number of decimal points too. Okay? So start on the inside. 0.04 divided by 12 plus 1. And then we're going to raise that to the 12 times 30 power. And then I'm going to subtract 1. So here, remember, you have to go out 2.313498. All right, so now let's go right into our calculator here. 833.12345 going out. We want to be as accurate as we can. And here we'll round this off, right? So you're going to have to put away, to have this $250,000, you're going to have to put away $360.20 each month. All right, so part B says, let's find out how much came from deposits. Well, look, you're doing, from your calculator here, you're doing $360.20. 12 times a year for 30 years. So So over the 30-year period, you made $129,672 in deposits. Not bad. So how much did you make in interest? All right. Well, again, so how much did you want to have saved? You wanted to have saved $250,000. And you subtract away how much you made in deposits. So it looks like, you made a lot in interest here. You made $120,328 in interest. So you can see here your interest rate pays a real big, obviously a real big component into how much, you're accumulating over time with interest. Let's now do one last problem, and just like I did with the previous formula, I really encourage you to pause the video and give this a shot, and then unpause the video and see if you get the same things I get. So I'll be quiet for a second if you want to pause, and then I'll solve it for you. Okay, so here's the problem. Hopefully you gave it a shot and pause the video, and if not, that's okay. So here's what you want to do. You want to save, okay? So you want to save, that's your A. You want to save a total of $500,000, so $500,000 for a retirement fund in 45 years. So you're given T is equal to 45. So you anticipate making regular end-of-month deposits in an annuity, okay? So, and you're going to do 12 times a year. And it's paid 7.5% compounded monthly. Okay, so it's your rate is 0.075. Okay, so again, how much should you deposit each month? And then how much of that $500,000 retirement comes from deposits and how much comes from interest? All right, let's do it. So you're just going to follow the formula here. So the amount you want $500,000. The rate you were getting was 0.075, so 7.5%, divided by 12. And that whole thing is going to be divided by 1 plus 0.075 divided by 12, raised to the 12 times, and then remember, you're going to save for 45 years. 45 years, okay? Long time. All right, at this point, grab your calculator. Let's figure out what the numerator is. So 500,000 times 0.075 divided by 12. That numerator is $3,125. Divided by, all right. So start in the innermost, 0.075, innermost part of the parentheses, divided by 12. Then add 1. And then we're going to raise that to the 12 times 45 power. And then subtract 1. All right, so look, remember, you got to go out 6 decimal places here if you're going to do this, piecemeal. All right, so it's 27.918944 when I round it. $9,189 44. All right, well, let's figure it out. We're going to take 3,125 divided by 27.918944. Wow, look at that. If you want to have $500,000, all right, and under this, 45 years and that interest rate, you're only going to need to deposit $111.93 each month. Wow. So you can see the time value of money here. All right. Just put money away. All right. So how much of this comes from deposits? Well, you're going to take your 111.93 times 12 months a year for 45 years. And you're going to get, wow, look at this. This is crazy how much of this is coming from interest. $60,442.20. So how much you made in interest here? Well, remember, you're going to have $500,000. Minus you only put away $60,442.20. That's why it's important to start saving early and often, because your money could, over a long period of time, look at how much of that was interest, okay? $439,000. $557.80. Most of it, the vast majority, was interest here. So start saving early and often, and then one day when you go to retire, you'll have a very sound and safe retirement. All right, class. I hope this helped this video here, and if you have any questions, please let me know.